As Kelly already introduced the subject, I did my master thesis about optimizing aerospace composite structure modularity with SEER and MATLAB. I'll first briefly introduce the subject and then go into how to integrate SEER with MATLAB. The title of my thesis was Cost-Weight Rates for Modular Composite Structures, and the goal was to assess whether the concept of modularity can be used to increase the cost-weight efficiency of composite aero structures. Well, of course, there's already a lot of modularity playing a role in composite aero structures, but in my thesis I wanted to quantify the effect of modularity on the manufacturing cost of the complete structure. So what was investigated can be shown in a simple diagram where you have cost on the y-axis and weight on the x-axis. A non-modular design would have a specific cost and weight, and either when you increase the modularity, the weight of the structure will always increase, and we were hoping to find one of these three effects, and of course it would be nice to find the green effect where increasing the level of modularity would significantly decrease the cost of manufacturing the structure. So this was basically what I was doing in my thesis. And in order to do this, I set up a methodology, mainly writing MATLAB code. In MATLAB, I wrote codes to do weight optimization of the structure. So I was designing fuselage stringers and fuselage frames for aircraft fuselages. And I did the weight optimization using a gradient-based optimization in MATLAB, for example. And I also wrote an optimization to optimize the modularity of different structures. So for a certain level of modularity, the weight of the structure would be optimized. However, I also needed to determine what the cost would be of manufacturing these different structures. In order to do this, I used the SEER for manufacturing software with the Aerostructures plugin. But in order to be efficient, I needed to integrate the SEER for manufacturing software with MATLAB. So I could do all the optimization parts for weight and modularity in MATLAB and then simply let MATLAB call SEER to do the cost analysis. And this is what I will describe in this presentation, how I have solved this problem. Well, the requirements on the MATLAB integration are the following. A lot of cost estimations need to be performed, and this is why there needs to be some automatic interface to do this. It would not be possible to get all the modular structures in MATLAB and then manually determine the cost of these structures by going into the SEER GUI. These cost estimations were for quite complex structures with a lot of different stringers around the fuselage. There are also some wet plates in the frames which could have cutouts with reinforcements on them. So they're quite complex things to analyze. And then I needed to be able to adjust key variables in the cost estimation depending on the MATLAB results for the weight optimization and modularity optimization. So the capabilities of SEER for manufacturing that I used were the following three. I ran SEER in server mode, which means that if you start up SEER in server mode, you can give it a command file, and then it will analyze this command file automatically and give you back some results. So I needed command files, which I will show later how this works, and I needed the FlexPort output of the SEER program, which gives you a basic text file with a summary of the results. So let's take a brief overview at how the interface works. Well, first of all, you need to get the SEER settings, which are defined in MATLAB. This is the location of your executable and stuff like this, just basic settings you need to define. And you'll get the relevant structural properties from other MATLAB routines. So for example, you could get the width and the thickness of a stringer from the weight optimization done in MATLAB, and then the MATLAB routine will write a SEER command file, and this SEER command file can then be run by SEER in server mode. So SEER is not yet running in server mode. SEER is started up in server mode at first, and then once it's in server mode, you can give it a lot of command files continuously. Then once the command file is analyzed, the results are exported to Flexport files, which are then again imported in MATLAB. And if you want to do another cost estimation, you simply define a new command file, and the whole thing will be done again until all cost estimations are done, and then SEER for manufacturing is closed automatically. So let's look at these command files. If you go into the GUI of SEER, you can simply define all the variables, and then beneath tools, you can create a command file, and this looks like this. It's basically a text file with all the commands that will need to be run by SEER in order to complete the cost estimation. And normally in this command file you would have all the numbers and all the settings that you have applied in the user interface. Well, in this case I've indicated some of the variables in red, and these variables can now be changed by MATLAB. So for example, over here we have the length of this part, and it's now called var length, and this string will be replaced by a number by MATLAB. So I call these command files the MATLAB command files, since they don't have only numbers but also the MATLAB variables that will be replaced. So let me briefly show you in a demo how you can set up your own small cost analysis in MATLAB. Well, over here we're inside MATLAB, and I've made a small file called demo SEER seminar to show you how it works. So the first thing we need to do is actually create a MATLAB command file. And we'll do this by starting up SEER. And then inside SEER, we'll first create a command file with variables. So if we do a new project, for example, we'll do a T channel. And in this case, we'll insert a work element. Again, just a simple T channel, and let's use the detailed composite package in this case. And the T channel is one of the knowledge base templates. So over here are all the variables you can set in SEER. You can set all the things which are static simply in the SEER interface, which is much more user-friendly than doing this kind of stuff in command files. In the end, once you have set all the variables, you'll do tools and then export commands. And you export the entire project to a file using the variables that you have set. Well, in this case, I've already prepared the file for the demo, of course, to save some time. But let's save this one on the desktop. So here you have your command file with all the numbers that have been defined in the interface. So in this case, if we want to change the length in MATLAB, we'll have to replace this number by var L. And these numbers over here are the width and the thickness of the T channel, which we'll also replace like this. And now we can save this file. And the next step is to go to MATLAB. And the main function that I've developed is called perform cost estimations. And the input is the different designs that come from the MATLAB optimization. So let's take a brief look at the SEER settings. You have an overview over here where you can define multiple things. Most importantly is, for example, the location of your executable for SEER for manufacturing and the name of the command files that you are running. If we would go through the whole perform cost estimation function, we would see the same thing as we saw in the workflow diagram earlier. In the end, it's also very important to adjust the MATLAB command file that we have created, and this is done in the write SEER command file function. So over here you see what I've just shown you in the command file. The var_l variable is replaced here for a number that has been found in MATLAB by the optimization routine. And this is done for all 5 variables over here. So if we now want to analyze a range of T-channels, we can simply set the numbers over here. So in this case, I specified a certain length and thickness, and I say that the width and the height of the channel will be changed, going from 1.86 to 2.86, and the height from 0.93 to 1.43. So now everything's set, and if we press the run button, you can see that SEER is now started in server mode. And in the command window, you can see the progress of what's happening. So now the first T channel is analyzed, and it opened the results file that was created by SEER. And it will do this for the 11 different channels that were created. On the left here, you see that some text files are created. Most of them are deleted again to save some space on your hard drive. It's almost finished. Now over here we have, just to show you the results briefly, there's a plot with the total manufacturing cost for 10 T channels. And of course, on the left side are the smaller designs which are a bit cheaper to manufacture. And you can see the trend in labor and tooling cost as the size of the channel increases. This is just to show you how easy it can be to set up the analysis. In my thesis, I have used a lot of variables. I think like 15 to 20 different variables were changed by the MATLAB routine, and then the analysis of structures with, for example, 80 to 100 stringers was done by SEER. So this was the demo. Let's see. In conclusion, there are some limitations to the current interface of SEER and MATLAB. It's not very suitable at the moment to be used as an objective function optimization. So what I've done in my thesis, I have optimized the weight of the structure and the modularity of the structure, but the cost estimations were done after the structure was already optimized. And so this interface now is very suitable to do a lot of cost estimations automatically. Also, it's limited by the maximum amount of work elements that can be analyzed in the server mode by SEER for manufacturing. At some point, you have to exit SEER again and restart it in order to do more analysis. And I myself have some ideas for improvements, which would be to make the interface more suitable for optimization purposes, of course. This should be done by finding a way to speed up things. Another thing would be to create an automatic export function in SEER, where you can automatically create MATLAB command files. I would imagine that this would be under Tools, and you do export MATLAB command file, and then you get a menu where you can select which variables should become MATLAB variables instead of having the value that you would give in the SEER user interface. And another thing that could accompany such a thing would be a user interface in MATLAB, where you can also set up your cost analysis using the basic command file that you created in SEER. And then you can, for example, import this basic command file in MATLAB, and you would you could set some settings like the range of length that you want to analyze, or the range of the width of the stringer that you want to analyze in the optimization. Or if it's suitable for optimization, you could say which variables are the design variables in your optimization function, and then you could automatically create a MATLAB objective function for your optimization. Well, this was my presentation on the SEER-MATLAB interface. So if you have any questions, please ask.